All right, welcome back to section 7.3 on sample means. And on the second part of the video for 7.3 on day 2, we're going to look at the central limit theorem. And we just finished looking at normal distributions. And when we sample from a normal distribution, when the population is assumed to be normal, that we know the shape of our sample distribution of the sample means will also be normal. But most population distributions are not normal. So the question is, what is the shape of a sampling distribution of sample means when the population distribution isn't normal? Well, it's a remarkable fact that as sample size increases, the distribution of sample means changes its shapes. It looks less like that of the population and more like a normal distribution. So as our sample size increases, as each sample gets larger and larger, the distribution of the sample means from those sample sizes will begin to look a lot more normal. And when the sample is large enough, we'll talk about that. What does it mean to be large enough? When my sample size is large enough, the distribution of the sample means is very, very close to normal, no matter what shape the population distribution started with, as long as the population has a finite standard deviation. In other words, as long as we know what that standard deviation is. So, we draw a simple random sample of size n from a population. So in other words, I've got this population of data. I'm going to make just a simple random sample of some size n from that population. And that population has some mean and has some finite standard deviation sigma. Well, the central limit theorem, which we'll abbreviate from here on out to CLT, says that when n is large, when my sample size, when I go and sample from that population, if that sample size is large, and again we'll talk about that in a second, but what does it mean to be large? The sampling distribution of the sample mean of the x bars is approximately normal. That's huge. That's huge. What it's saying basically is, it doesn't matter what the population distribution looks like. If my sample size is large enough that the distribution of all those samples of that same size will be normal. That's huge. So let's consider a little example here. This is from an applet that you could experiment online as well too. And this is a distribution that is certainly not normal. And we're going to sample from that. So what we could do is I could go in and I could do sample sizes of size 2. So in other words, I could take two pieces. I get to get one data from here and one data from there, and the mean would be somewhere in the middle here. Well, it might happen that I have one piece of data here and one piece of data here, and the mean would be right about here. Well, if I do this many times, the distribution of the means of those sample sizes of size 2 and did the sampling distribution for that, this is what it would look like. Certainly doesn't look normal quite yet, but if I were to do my sample sizes of size 5 from this distribution, so randomly come into this distribution and I'd sample 5 pieces. I might get 2 from here, and 1 from there. I'd add all 5 of those up, divide by 5 to find the mean of that sample size of size 5, and maybe it ends up right in this area. And continue to do that. Do many samples of size 5, plot them all out, and that sampling distribution, as you can see, starts to look a little more symmetric, a little more normal. Well, as I move to sample sizes of size 10, so again, taking 10 pieces of data from this distribution. So again, maybe I get 4 from here, and there were 2 from there. Add up all those 10, divide by 10. And find the mean of that. It's going to probably be somewhere right about in here, possibly. And you can start to see that as my sample size increases. Doesn't say anything about how many samples I do, but as my sample size increases, you can see that starts to look normal. In fact, if I move up to a sample size of size 25, it even starts to look a lot more normal and has a lot less variability as well. So as our sample size, as the size of the individual samples increases, what do we notice? Well, even when the population distribution is very non-normal, this is very non-normal, what we notice is that the sampling distribution of the sample means. Okay, so again, this is the sampling distribution of the sample means. Okay, as those sample sizes get larger, okay, it starts to look approximately normal. And it starts to do so with sample sizes even as small as 25. Well, here are the rules. If the population distribution is normal, then so is the sampling distribution of X. That was back from the first half of this lesson in the day 1 video, that if the population distribution is normal, well, then we know the sampling distribution of the sample means is also normal. And that's true no matter what the sample size is. But if the population distribution is not normal, if it is not normal, the central limit theorem, the CLT, central limit theorem, tells us that the sampling distribution of those sample means will become normal in most cases when our sample size is greater than or equal to 30. So there's that magic number we've talked about before, and making sure that when we do samples, we do a sample size of about 30 or more, because then that allows us to use or to assume that the distribution of our sample means is normal. All right. So again, the central limit theorem allows us to use normal probability calculations to answer questions about sample means from many observations. Again, we're going to do many samples of a size 30 or more, especially when the population distribution is not normal. Because again, if the population is normal, our sampling distribution of our sample means will be normal. But if the population distribution is not normal, or we don't know if it's normal or not, you're going to want to make sure your sample sizes are 30 or above, because in the distribution of those sample means of those samples of size 30 or more will be approximately normal. And then we can use the normal CDF on our calculator to do some calculations. All right, so again, we've got our population out there. There's some mean of that population. So what we do is we take simple random samples from this population, find that X bar. Now, if the population is not normal, if you don't know it's normal, make sure that this size is 30 or more. If this population was normal, it doesn't matter what size we take. We will know that that distribution of all of these X bars will be normal. But again, if it is not normal, if our population is not normal, make sure your sample size is 30 or more, because then the distribution of all of these sample means will become normal or approximately normal, with a mean the same as the population mean, but our standard deviation will be a little bit tighter, and we'll calculate the standard deviation of our sample means, of our sample distribution, to be sigma divided by the square root of n. So, with that said, should be able to find the mean and the standard deviation of the sampling distribution of a sample mean. Again, our mean, the mean of our sample means, of our sample distribution, is the same as the population mean. The standard deviation of our sample means, of our sampling distribution, is the population standard deviation divided by the square root of n. And again, in order to do this, we have to check the 10% condition, which is again 10 times our sample size has to be less than or equal to our population, or as the book states, our sample size has to be less than or equal to 1/10 of the population. The shape of the sampling distribution of a sample mean is affected by the shape of the population distribution of the sample size. So again, if the population distribution is normal, the distribution of our sampling distribution will also be normal. But if our population distribution is not normal, you probably want to make sure that when you sample that your sample sizes are 30 or above, because when we take many samples of size 30 or above and look at the sampling distribution of that, if the population distribution is not normal, the distribution of those sample means should become normal, or will be approximately normal, when our sample size is again 30 or above. And if that's the case, then we can use the normal distribution to calculate probabilities involving sample means. Alright, well, that should allow you to go and do the second part of the homework from 7.3 on the central limit theorem, problems 57, 59, 61, 63, and 65 through 68. Good luck. We are now done with Chapter 7, and I wish you luck and success.